In this section, we're going to continue our talk of inverses. And we're going to talk about inverses of trig functions. Now, if I draw the cosine of x, probably looks something like this. And if I draw its inverse, I think that's going to look something like, oh, let me do this in a different color. Something like this. So the reflections over y equals x, and probably not the best drawing. This thing snakes back and forth over the x-axis. This thing's going to snake back and forth over the y-axis. But they are reflections over the line y equals x. Now some notation or some terminology that you need to be familiar with. There's the term inverse sine, could be written like this. And realize that if James or AP or anybody mentions arc sine, that means the same thing. That sine inverse x means inverse sine. And this abbreviation, I guess, shorthand for arc sine, all four of these things mean the exact same thing. Now, if we're talking about y equals cosine of x, what is x? Well, x is an angle measure. Maybe it's in degrees, maybe it's in radians. This being calculus, it's probably in radians. And y is going to be some number. And cosine is always between 0 and 1. So in this case, it's some number, negative 1, not 0 and 1, negative 1 and 1. Okay. But if we take the inverse, what happens is domain and range, they change roles. And so this thing right here becomes an angle measure. And in an inverse function, you take the cosine inverse of some number. And that some number is going to be between negative 1 and 1. So realize that when you are trying to find an inverse, you're finding an inverse of a number and trying to find the angle measure at which that, in this case, cosine occurs. All right, now let's find cosine inverse of 1/2. Now for cosine, some things you need to know. Cosine inverse. You're looking for angle measures. The angle measures that are going to answer this are between 0 and pi. Sine inverse, tan inverse. These, the angle measures you're going to find, are going to be between negative pi over 2 and pi over 2. Those are the kinds of solutions you're going to get. Those are the y values you're going to get. So cosine inverse of 1/2. All right. What that is asking, and as I look at a unit circle here, what angle measure as a cosine of a half, because if I were to switch this around, I would say 1/2 equals the cosine of y. So what angle measure has a cosine of a half and a half on the x's? I think that's right here. And so I'm saying if I'm limited between 0 and pi for my answers for cosine, I am going to have to say that that occurs at pi over 3. That is where the cosine, that is where the x value is 1/2. Now tangent's a little tougher. Tangent is sine divided by cosine. And so I want the tangent. If y equals tan inverse of square root of 3, that means square root of 3 equals the tangent of y. So what angle has a tangent of y? And again, I am talking about angles between negative pi over 2 and pi over 2. Well, now let's see. I'm wondering. I'm just wondering. Does that maybe happen right here as well? Let's see. If I said that y was pi over 3, I think that's it, because tangent of y is square root of 3. If y is pi over 3, I would have to take the sine of pi over 3 divided by the cosine of pi over 3. And is that indeed square root of 3? Well, let's see. This is square root of 3 over 2. This is 1/2. I would never divide by a half. Instead, I would multiply by its reciprocal. And sure enough, I would get square root of 3. So, by knowing my unit circle, by first of all converting into something I have more experience with, a lot more experience finding tangents of angles than tan inverses of angles. Cancellation property of inverses: if you take the sine inverse of the sine, well, you just end up with x. These two things cancel each other out. Sine inverse and sine cancel each other out. And this is for x's. Now remember, if I'm taking the sine of something, that's an angle measure. And so that sine, that x value, that angle measure between negative pi over 2 and pi over 2. Also, if I take the sine of the sine inverse, they cancel out. We're left with x. But here, if I'm taking the sine inverse of something, that means it's a number, and sines are numbers between negative 1 and 1. But realize that if you take a trig function and its inverse of each other, you're just left with whatever that x value is. All right, cosine inverse of a half. That's in parentheses. Let's do that first. I think we already found that. That was pi over 3. So I'm really looking for the sine of this angle measure, pi over 3, which I know is square root of 3 over 2. Now the same thing's going to happen down here, and actually comes out to be exactly the same. This angle measure right in here is again pi over 3, and so it amounts to being the same question. Let's find the sine of that angle measure, and that is square root of 3 over 2. But this last one, this is not something that is going to be on the unit circle. I don't know an angle measure that has a sine of 3/5. So when I'm given something like this, the method that I'm going to use is called the triangle method. I'm looking for some angle theta where the sine inverse of 3/5 gives me that angle measure. Now that means that 3/5 is the sine of theta. And when this isn't a unit circle thing, or even if it is, I guess, we could use this method. I'm going to draw a picture of a right triangle. And I'm going to put theta as this angle right here. Now what I know is that the sine of that angle is 3/5. So the opposite over the hypotenuse, because that's what sine is 3/5. Now, am I going to also have to know this mystery side down here, which in this case isn't very difficult. We recognize this as a 3-4-5 right triangle. So this is a picture of our triangle. And I'm looking for the tangent of, well, I'm looking for the tangent of theta. So here I am at theta. What's the tangent? What is tangent anyway? Tangent is opposite over adjacent I'd get 3/4. Now this triangle method is something that we're going to see a little more often, but this is a nice way of handling non-unit circle type numbers. So we'll get some practice on that as well as part of our assignment. Now the triangle method for finding derivatives of inverse trig functions. There's two of them that you need to know. You need to know the derivative of sine inverse, the derivative of tan inverse. So we're going to work on that. And I'm going to use this thing called the triangle method. Well, we just talked about it, but let's take a look. If y is equal to the sine inverse of x, that means x equals the sine inverse of y. I'm sorry, not inverse. Equals the sine of y. So I'm going to draw that situation. Here's the angle, that's y, this is a right triangle. And the sine of y is x. That means sine is opposite, so I'm going to put an x there. Over hypotenuse, I'll make that 1. And now the sine is x, opposite over hypotenuse. Now, always have to find this mystery side. And so I'm going to use Pythagorean theorem. Right now, I guess I'll call this question mark. And let's figure out what question mark is. I know question mark squared plus x squared is equal to 1, or 1 squared, which is 1. So that means question mark squared is equal to 1 minus x squared. And so question mark is equal to the positive or the negative square root of 1 minus x squared. Well, I think it's pretty obvious that we can't have the negative. We can't have a side that has a length that is negative. So we'll keep that square root of 1 minus x squared. Okay. So now I've made my triangle. That's awesome. Now I know x is equal to the sine of y. And if I take the derivative, now I got to find y prime to remember, so let's take the derivative of this. That's 1. Let's take the derivative of this, and I'm going to have to chain rule that. That's going to be the cosine. Don't mess with the inner function. Times the derivative of the inner function. And that's what I want to find is y prime. So y primed will be equal to 1 divided by the cosine of angle y. And now I look over at my triangle over here, and I can say y primed is equal to 1 divided by, now what's cosine? Cosine of angle y is going to be adjacent divided by hypotenuse. And so the derivative of the sine inverse of x, if y is equal to sine inverse of x, y primed is equal to 1 divided by the square root of 1 minus x squared. Every single time, that's what the sine inverse of x will be. That's what the derivative of sine inverse of x will be. Well, let's practice that again. It makes some sense, but the more we practice it, the more it'll make sense. Same thing's going to happen here. If y is tan inverse of x, x equals the tangent of y. I'll draw a triangle of that situation. Where this is the angle known as y. And the tangent of that angle is x. Now, tangent is opposite over adjacent. And now, if I take opposite over adjacent, I do indeed get x. And how big is the hypotenuse? Well, the hypotenuse, let's see, how big is that going to be? If I take 1 squared plus x squared, I get my hypotenuse squared. And so my hypotenuse is going to be the square root of 1 plus x squared. Next thing I do is I work with this equation and I find its derivative. And the derivative, let's see, the derivative of x is 1. Derivative of tan y. Chain ruling, I'm going to get secant squared y times y primed. So y primed is equal to 1 divided by secant squared of y. So what is y prime going to equal to? Well, secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, that means secant is hypotenuse over adjacent. I'm going to say that the secant of angle y is hypotenuse over adjacent, which is 1. So this is the secant of angle y. So I've got to take 1, and I've got to divide it by this thing being squared. So if y is equal to tan inverse of x, y primed is 1 over 1 plus x squared. 100% of the time. And those are the two inverse trig functions that we'll be expected to know the derivatives of when it comes to the AP exam. Now, what if? What if this isn't just a plain old x? I know that if y equals sine inverse of x, y primed 1 over square root of 1 minus x squared. So what if y is equal to sine inverse of natural log? Well, I'm going to chain rule this thing. Let's see, it's going to be 1 over square root of 1 minus. This thing is what gets squared. So I better square this thing. But I also have to remember, because of the chain rule, because there are parentheses, I need to multiply by the derivative of this. So I'm going to multiply by 1 over x. So my final expression for y primed is 1 over x square roots of 1 minus natural log of x being squared. And I don't have to make the triangle. If I want to, I can, but I don't have to. What about this guy? I'm going to try and get away without making the triangle. I do know that if y is equal to tan inverse of x, that y primed is equal to 1 over 1 plus x squared. I've proven that. So I just got to take the thing in parentheses, square it, and stick it down here. So here, y primed is equal to 1 over 1 plus. This thing in parentheses being squared. But then I got to multiply by the derivative of this thing. And the derivative of e to the something is e to the something times the derivative of that something. So my final answer for y primed, when I clean things up, I'm going to have a 2e to the 2x divided by 1 plus. And I could just write it like this. Or I could call it e to the 4x when I multiply those exponents. Either way, that's your derivative. So when you find the derivatives of trig functions, don't forget they may involve chain rule if what you see in the parentheses isn't just a plain old x. Now, in our textbook, there is a table of inverse trig functions that you might find helpful on page 457, but realize what I'm going to ask you on an assessment, what AP is going to ask you in May, is only derivatives of sine inverse and tan inverse. James, on the assignment, James might ask you something that involves a table on page 457.